Machine learning. It is a buzzword I think everyone here in the audience has heard before, but I will also claim it's a lot more than just a buzzword. How many here in the audience have experience with machine learning? It's a good quarter of you, that's good to see. When I started learning machine learning, I did not really understand how the different algorithms worked and what the main difference between them was. I find it difficult to know where I should start. In this lightning speech, you will learn the fundamental difference between the different categories of algorithms. And I think this will help beginners, but also those who have some experience with machine learning to start off with the right algorithm on the next problem. So real quick about myself, my name is Joakim Lehn. I am a technical team lead and a manager at the Nordic consultant firm Knowit, and I work and live in Oslo, Norway. I've been fascinated about machine learning for the last 2 or 3 years, and I've done some machine learning projects both professionally and personally. And I must say there are many different algorithms out there. Just take a look at this. It's a good thing that we have a lot of algorithms, but it's difficult to understand where you should begin. Obviously, some algorithms are more suited for certain problems than others, and the results you get will vary greatly of how well the chosen algorithm fits the problem. But luckily, you can divide the different algorithms into 4 different categories of machine learning. You got supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. And when you face a machine learning problem, it is important to understand what kind of category it fits into. So we're going to explore these 4 categories today. But before we get to the good stuff, I just need to explain 2 key words here so that everyone in the audience is on the same page. We got something called features in machine learning. A feature is a property of your training data. And the output you get from a model is called a label. So briefly, you can think about it as features input and labels is output. Partially true. Let's explain it with a quick example. If you're trying to predict the height of a person based on age and gender, then age and gender are features, and the height which you want to predict is the label. If you have a training set with examples of people with their corresponding height to age and gender, then you have a labeled training set. So the first category we're going to explore is something called supervised learning. And in supervised learning, the training data consists of a set of training examples. You have a labeled training set. And the idea is to find the most optimal model parameters to predict unknown labels on other objects, meaning new examples. Let's explain it with a couple of examples. Let's say we want to estimate the value of a used car given its age, color, make, mileage, you name it. A machine learning algorithm can estimate this based on a training set with examples of corresponding values. That means that if you feed an algorithm with many examples of previously sold cars with their features, the mileage, make, age, so on, and the corresponding label, what value they were sold for, it can estimate what other cars will be worth as well. Another example is mail. This is a typical supervised machine learning problem. Is the mail spam or is it not spam? If you give an algorithm many examples of mail which we know is spam, and also many mails that we know is not spam, then hopefully the algorithm can estimate if a new email is spam or not. One algorithm in the supervised domain is called decision trees. And I like decision trees in the way that it's kind of intuitive to understand. It sort of thinks the way humans think. We create a tree with different nodes, and in every node, we choose the best split among all features. We make this procedure recurrently for each node, and we finish when we meet a stopping criteria. I'm going to illustrate it with an example. Let's say you want to answer the question, should I accept a new job offer? Well, you might start asking yourself, is the salary above some threshold? If it's not, most of us will say no. But let's say the salary is acceptable. Then you might ask yourself some other questions. Do you have to commute for more than an hour? Do they have free coffee? Is the technology they're working with interesting? Is the boss nice? And so on. And based on questions like this or features like this, you will end up at a stopping leaf and either accept or decline the job offer. The next category is called unsupervised learning. And in unsupervised learning, you have only input data and no corresponding output variables. That means we have no labels in our training set, or at least if you do, you're not going to use them for the unsupervised algorithms. And the goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data set. So you could argue that there's no perfect model or a teacher here involved there. The algorithms are just left on their own to discover and present the interesting structures in the data. A couple of examples here could be if you want to group customers by their purchasing behavior. If many customers who bought an item A also bought item B, then the system would typically recommend item B to customers who are interested in item A. Pretty logical. Another example is Netflix. Netflix video recommendation system consists of a series of unsupervised learning algorithms and much more, of course. Within the unsupervised domain, one great algorithm is called k-means. And k-means is one of the most used clustering algorithms out there. The basic idea of k-means is that you want to divide all the data into k clusters, where k is a number. The algorithm starts off by selecting random k points from your data and name them center of clusters. The cluster of other objects are defined by the closest cluster center, and the algorithm is tuning this by trying to minimize a cost function. And you tune this algorithm by selecting the k number of points, meaning you have to decide how many clusters should there be in my data. So you have to have some understanding of what the data consists of. This algorithm or other algorithms in the unsupervised domain can, for instance, be used to try to find the optimal place to open a new hotel in a city. Let's say that you're super rich and you own a hotel store. Then where should you place your hotel? You could try to create clusters using different features. Let's say you get data of proximity to tourist attractions around the city. Is this location close to downtown? Are there restaurants nearby? And so on. And hopefully, if you gather a lot of this data, you could create some clusters which indicates where you should place your hotel. The third category of problems falls between supervised and unsupervised problems and is logically called semi-supervised learning. And here you have partially labeled data. And many real-world problems falls into this area, and that's because it can be really expensive or time-consuming to label data. And other times you might require access to a domain expert and able to label it. Whereas unlabeled data is typically cheap and typically easy to collect and store. And a mixture of supervised and unsupervised techniques can be used here. A good example could be a photo archive where you have some images that are labeled. Some people have gone through each photo and said that this photo contains a cat, this photo contains a person, this is a mountain. And most of the pictures are unlabeled. The last category of problems fall into something called reinforcement learning. And reinforcement learning is not like any of the supervised algorithms, in the sense that you don't have any labeled datasets and you don't have any unlabeled datasets. You don't start out with the training data. Like this figure tried to explain, you create some agent that's going to have some state, and it's going to do an action on an environment. And based on its action, it's going to get a reward or a punishment from the environment and end up in a new state. And this process is then repeated. You can try to think about this as by imagining that you're a robot in some strange place. You can perform activities and get rewards from the environment. And after each action, your behavior is getting more complex, more clever. So you're training to behave the most effective way on each step. And when you think about it, that's kind of the way us humans learn. For instance, when babies try to walk, they try and they fail and they fall and they hurt themselves, but they learn and get better and better. And for the last few years, we have made some incredible progress within the reinforcement domain. One example is AlphaGo by Google. Go is an ancient Chinese board game. And unlike chess, which is also really heavy to be brute force, but Go is much more complicated. It has many more combinations. So everybody's always thought about Go as you have to play by intuition, which is really difficult for computers. But AlphaGo managed to beat the best player in the world. And it learned by playing as itself over and over again. No human interactions at all. And it made moves that humanity has never seen before. And some of them are now taught at Go schools in China. They have Go schools in China. That's really cool. I think it's also really cool that computers can teach humans something new as well, not just the other way around. Another really great example from recent time is OpenAI. OpenAI is a company that created an AI that managed to beat some of the best players in the world in Dota 2. And Dota 2 is a real-time game. And the world was really shocked to see that machines can beat humans in this game. It's vastly more complex than traditional board games. They also managed recently to beat a 5 versus 5 team, 5 computers versus 5 humans, which is even more impressive. This is my personal dream project. I'm hoping that I one day can have time to create an AI that can beat me in Mario Kart. And if I did, that would be reinforcement learning as well. I think it's going to be difficult because I'm quite good in Mario Kart and not so good in reinforcement learning, but we'll see. So that was the 4 categories. In supervised learning, all the data is labeled. You have examples. And the algorithm learns to predict the output from the input data. Unsupervised learning, all data is unlabeled. And the algorithm learns the inherent structure from the input data. In semi-supervised, some data is labeled, but most of it is unlabeled, and a mixture of supervised and unsupervised techniques can be used. Reinforcement learning is an area of machine learning concerned with how a software agent ought to make actions in an environment so as to maximize some notion of cumulative reward. So that was the 4 different categories of algorithms. And hopefully, when you face your next problem, you will understand which category it fits best into. If you can find a category, then it's easier to find a suitable algorithm. Now, machine learning, as I said in the beginning, might be a buzzword. But for those who haven't tried it yet, remember it's happening right now out in the world, so just go out there and learn it. Thank you all.